Welcome back to the course on optimization methods for civil engineering. So, today I will discuss about metaheuristic optimization method, or basically I will introduce what is metaheuristic optimization method. So far we have discussed the classical methods. So, right now you know what is classical optimization technique. So, you have learned the necessary and sufficient condition for optimality. Then we have discussed the line search technique. Okay. So, line search technique, that means for a single variable optimization problem. So, how you can find out the optimal solution of that particular function. Then we discuss how to solve the multivariable problem. So, what you are doing, basically you are doing couple of line search. So, you are taking a direction, and then along that direction you are trying to find out the optimal solution. So, we have discussed few algorithms like the Newton's method, the steepest descent method, and the univariate method, as well as the conjugate direction method. Now, you look at these algorithms. So, the basic assumption when we derive this your algorithm was that the function is a convex function. That means, there is only one optimal solution. So, therefore, if we apply this algorithm for a non-convex problem, so having more than one optimal solution, so in that case what you are getting? You are getting only the local optimal solution. That means, you will get a local optimal solution of the problem. So, you may not get the global optimal solution of the problem if you apply these algorithms. So, let us initially look at what is the disadvantage of classical optimization methods or techniques, and then I will discuss about metaheuristic optimization technique, which are capable of finding the global optimal solution of a non-convex problem or a difficult problem. Okay. So, let us see the difficulties or you can say disadvantage of classical optimization methods. Now, as I said, the classical optimization techniques are useful in finding optimal solution or unconstrained maxima or minima of a continuous and differentiable function. Okay. So, the function has to be continuous and differentiable. Why? Because we are using the gradient information. So, therefore, the function has to be continuous as well as differentiable. So, look at the first function. This is a simple function. We have only one optimal solution somewhere here. This is a convex function, and I can easily solve this problem using classical method. So, you just do a line search, you can apply the golden section search method, you can apply the interpolating method, you can apply the Newton-Raphson method, or you can apply any line search technique. So, single variable optimization technique, you can find out the minimum of this particular function, because there is only one minima and you can easily find out the optimal solution of this problem. Similarly, if I take this two variable function, this is also a convex function. Okay. This is also a convex function. So, you apply any methods like Newton's method or univariate method, conjugate direction method, steepest descent method, you search from any point and finally, you will get the optimal solution of this particular problem. So, these are simple problem, and I can say these problems are convex problem. So, therefore, if we apply the classical optimization methods, so you will be able to find out the optimal solution of these problems. So, there is no need to apply any other algorithms, because the classical algorithms are capable of solving this problem. And you know that when we have derived this, or when we have discussed about the classical optimization techniques, mainly line search, as well as after that we have discussed the different methods to get the direction. I said that the function has to be a convex function. That means, under the assumption that the function is a convex function, and we have derived this, or we have derived these algorithms. Okay. Now, let us see, I would like to show you one example problem. Suppose this is a function and we have only one optimal solution somewhere here. So, we have only one optimal solution somewhere here. Now, if I apply the reason elimination technique. Okay. So, in this case I have applied, suppose, the interval halving method. So, I have shown you the solution at different iteration, and this is the beginning. The initial length of the search space is 4. Okay. So, lower bound is 2, upper bound is 6. Okay. So, lower bound is 2 and upper bound is 6. Now, if I apply the interval halving method, so in that case after one iteration, okay, in the second iteration I am getting the lower bound equal to 3 and upper bound is 5 and the length is equal to 2. Then in the next iteration the length I am getting 1, lower bound is 3, upper bound is 4. Then if I continue this iteration, so I am getting length equal to 5, then 0.25, something like that, and finally I am getting a very small length, and it is, or the value of L is 0.00024414. Okay. So, I am getting this particular solution. Okay. So, this is the optimal solution of this problem, or I can say this is your X star. So, what I am telling here, so if you have only one optimal solution, if your function is a convex function, so you apply this algorithm, okay, and you will get the optimal solution of this particular problem. Now, I would like to apply this same interval halving method on this particular function. Now, just see, this function has two optimal solutions somewhere here and here, or maybe there may be other solution. Okay. Now, if you apply the interval halving method here, I have taken lower bound equal to -2, upper bound equal to +6. Okay. Now, after the first iteration, so this is the initial solution, or you can say the initially lower bound is -2 and upper bound is 6 and length is 8. Okay. Then after one iteration, so I am getting 2 and 6. Okay. And if I continue this, then finally I will get the solution somewhere here. Okay. So, this is the optimal solution of this particular problem. So, this is your X star. Okay. This is your X star. So, what will happen that if there are more than one optimal solution, so in that case you will get one of them. So, you can apply, it is not that you cannot apply this algorithm on a non-convex problem. So, you can apply and you will get one of the local optimal solutions. So, this is a non-convex function and I have applied the reason elimination technique, though it was designed for a convex function, but I can apply this particular algorithm on a non-convex function and I will get this particular solution. Now, let us apply the Newton-Raphson method. So, in case of Newton-Raphson method, so what we are doing, that we are applying this equation, that is x I plus 1, which is equal to x I minus that first derivative at x I divided by second derivative at x I, okay, to get the optimal solution of this function. Now, just see. So, this is a non-convex function, okay. This is a non-convex function and there is a maxima here and there is a minima here. Okay. Now, if I apply the Newton-Raphson method here, suppose I have taken this as a initial point Okay. So, this as a initial point, that is -2 as a initial point, and if I apply the Newton's method. Okay. So, in the second iteration I am getting this point, in the third iteration I am getting this point, fourth iteration I am getting this point. So, finally, I am getting this solution. Okay. So, this is 1 x star, or you can say this is a stationary point and this is a maximum point. So, this is one solution of this particular function. Now, you take plus 6, that x naught equal to 6. So, in the earlier case I have taken the x naught equal to -2. So, from -2 I am getting this particular solution. Then if I take x naught equal to 6. So, in that case just see, in the second iteration I am getting this solution, third iteration I am getting this solution, fourth iteration I am getting this solution, and this is the solution of this particular function. So, this is another stationary point, is not it. So, this is another stationary point. So, therefore, what will happen? So, if you are taking -2, so you are getting this solution, and if you are taking +6, you are getting this particular solution. So, therefore, if you apply these algorithms, so you will get one of the solution, or you can say you will get the local solution from where actually you are starting. So, therefore, these algorithms are sensitive to initial solution. Let us take an example problem. So, this is f x and this is x. Suppose the function is like this. So, we have one solution here, and this is a maximum point. We have another solution, this is also a maximum point, this is another point, this is a minimum point, and this is also a minimum point. So, therefore, in this particular function we have two maxima. Okay. So, this is one maximum point, this is another maximum point, and there are two minima. So, this is one minimum point and this is another minimum point. Now, let us use the classical optimization method, that means any single variable optimization technique, to find out the maxima and minima of this particular function. Now, if I take this as my initial point x naught, then I will get this particular solution. If I take this particular point as my x naught, so I will get this particular solution. If I take this particular solution as x naught, so I may get this solution, and if I take this particular solution as x naught, so I will get this solution. So, therefore, what will happen? Depending upon your initial solution, and initial solution you have to define as a user, you have to define the initial solution, this x naught value that user has to define. So, depending upon what initial value you have provided to the algorithm, so you will get one of these optimal solutions. So, therefore, for a non-convex problem, or if you have more than one optimal solution of a particular function, then these algorithms are highly sensitive to initial point supplied to the algorithm, is not it. So, depending upon the initial point, suppose if you are supplying this particular initial point, then you may get the global maximum of this function, and if you are giving this particular point as an initial point, then you may get global minimum of this particular function. So, now in this case you know, actually you have seen this function and you can decide an initial point, but just look about if a problem having 100 variables. Okay. So, this is not possible to know actually what initial point you should take to get the global optimal solution of the problem. Okay. So, therefore, these algorithms are not capable of solving a non-convex problem or a problem having multiple optimal solution. So, if you apply these algorithms on such type of problems, in that case you will get a local optimal solution of the problem. Now, let us look at the limitations of gradient based classical optimization method. Okay. So, I already discussed that one, but I have listed down the limitations here. So, what you need? You need the derivative values, you need the derivative information, is not it. The second one, the objective function and the constraints have to be continuous and differentiable. So, I already said that one. So, because I would like to apply the gradient based classical optimization technique. So, therefore, the function has to be continuous and differentiable. Okay. So, this is the need, or you can say this is the one assumption, or this is the need. So, then what are the limitations? The limitations are the algorithms are not suitable for solving optimization problems with discontinuous function. So, now if your function is discontinuous, okay, it is not a continuous function. So, you will not be able to apply these algorithms. So, this is one limitation. The second limitation is the algorithms are not suitable for solving optimization problem having non-differentiable function. Okay. So, if your function is non-differentiable, it is continuous function, but non-differentiable. So, in that case you will not be able to apply these algorithms. Now, I would like to tell one point here. There may be a function, okay, it is differentiable, but question is that how you are calculating derivative. So, you have to calculate derivative using numerical methods many times. So, you need to calculate the derivative using numerical methods. So, I discuss about that one, how you can calculate the derivative using numerical methods. So, now in that case what will happen? So, many times you will face some problem in calculating the derivative of the function. Okay. So, therefore, these algorithms are not suitable for solving optimization problem having non-differentiable function, even if sometimes it is differentiable, but it is very difficult to calculate the derivative. So, it may take lot of time to calculate the derivative also. So, in that case also these algorithms are not suitable. Okay. Then the third one is the algorithms are not suitable for solving discrete optimization problem. Okay. So, discrete problem. So, I can say that if your problem is discrete in nature. Okay. So, in that case these algorithms are not your suitable, because that function is not a continuous function. So, similarly, if you have integer problem or mixed integer problem. So, many times what happens, suppose I can give an example of integer problem. Suppose you would like to design a particular your beam or column, okay, and I would like to design the reinforcement. I would like to minimize the reinforce requirement. So, okay. So, reinforce is, suppose you are giving in terms of diameter of the bar. Now, this diameter of the bar, so suppose you are getting 8.5, oh 8.5 will not be available, 8.5 mm bar. Suppose your optimal solution is 8.5 mm bar you need to use in that particular beam or column. Now, 8.5 is not available, okay, in the market, because either you will get 8 mm or you may get 10 mm or you may get 12 mm, then 16 mm, then 20 mm, like that. So, 8.5 is not available. Similarly, suppose you are getting 20.06. So, that is also not available. So, then either you have to use 20 or 25 or your 18 or 16. Okay. So, therefore, these problems are your integer type problem. So, either you can use 20 or 16 or 12, something like that. Now, in that case these algorithms are not suitable. Okay. So, if you are apply these algorithms, then you will get a value, suppose something like that, as I said, in this case 8.5 or 20.06 or 21.27. So, this is not available in the market. So, therefore, you will not be able to use this particular value. So, in that case, these algorithms are not suitable for solving integer problem or mixed integer problem. So, here there may be integer variable along with the continuous variable. Okay. Then the other limitation is the work under assumptions that the problem is a convex problem. So, I have already explained that one, that when we derive these algorithms, okay, so in that case we said that the function is a convex function, we have only one optimal solution. If the function is a convex function, okay, so convex function, and we have already discussed what is convex function and what is non-convex functions. Okay. So, these algorithms work under the assumption that the problem is a convex problem. So, entire problem is a convex problem. For non-convex problems, the algorithm can only locate a local optimum. Okay. So, if your problem, as I said, you can apply these algorithms on a non-convex problem, but in that case you will get a local optimal solution. So, you can apply provided the function is a continuous function and function is differentiable. Okay. So, in that case you can apply and you will get a local optimal solution of the problem. Now, question is that how to get the global optimal solution? You can try, you can use these algorithms to get the global optimal solution of the problem, but what you have to do? You have to change your initial point. Suppose you are starting with x naught equal to initially 1, maybe after that x naught equal to 5. So, for different x naught, okay, so you can try and just see whether you are getting a better optimal solution of the problem. So, you can apply on a non-convex problem, but in that case you will get the local optimal your solution of the problem, or a local optimal solution you will get. Now, user has to define a starting point. So, this is, you can say, another limitation, because I do not know, in case of a non-convex problem, if you have more than one optimal solution of a particular problem and I would like to find out the global optimal solution of the problem. So, in that case I really do not know what starting point I should take. So, but user has to define a starting point here, and you can say, suppose if I use a suitable starting point. So, whatever starting point you have given, luckily that starting point is near the global optimal solution of the problem, or you can say on that particular region where global optimum solution is there. So, in that case you will get the global optimal solution of the problem. So, user has to define a starting point, and you can say this is another limitation of classical optimization technique. Okay. So, why I am telling about this limitation? Because these meta-heuristic optimization methods are developed to overcome these limitations. Okay. So, when we will discuss about meta-heuristic optimization methods, okay, or technique. So, these algorithms are actually developed or designed to overcome these limitations of the classical optimization methods. I hope this is clear to you. Now, I have shown you some functions here. So, I can apply the first function is a convex function, is not it? Convex function. Okay. So, I can apply the classical optimization technique and I can obtain the global as well as local optimal solution of this problem, and this is a local optimal solution as well as the global optimal solution of the problem, because this is a convex function. Now, this is a non-convex function, is not it? This is a non-convex function. So, in this case also I can apply the classical optimization technique, because the function is differentiable and the function is continuous. So, I can apply the classical optimization technique, but I will get one of the solution. If you have multiple optimal solutions, then in that case you will get one of that if you apply the gradient based classical optimization technique. So, you can apply here, but depending upon what initial solution you have provided. So, you will get one of the optimal solution of the problem. Now, this is a discontinuous function, the third function. So, I will not be able to apply the classical optimization technique. The function is not continuous. Okay. Then similarly, this particular function is non-differentiable at this particular point. So, therefore, I will not be able to apply the classical optimization technique, and similarly here also this is discontinuous function, this is also a non-continuous function. Therefore, I will not be able to apply the classical optimization technique. Okay. And this one is you have discrete source space. Okay. So, solution can be here, solution can be here, solution can be here, solution can be here, solution can be here. So, this is not a continuous function. So, you will not be able to apply the classical optimization technique or gradient based classical optimization technique for solving or for finding the optimal solution of this particular function or particular problem, because this is discrete in nature. Okay. So, either you should get this solution, or you should get this solution, or you should get this solution. There is no solution here. Okay. So, in between there is no solution. So, therefore, you will not be able to apply the gradient based classical optimization. Similarly, you look at this particular function. So, let me discuss about this second function. So, here you just see there are 4 optimal solution of this particular problem. Okay. Now, this is a continuous function and this is also differentiable, but only problem is this is not a convex function. Okay. We have more than one optimal solution. Now, I can apply the classical optimization technique because the function is differentiable and continuous. Okay. Now, if you take x naught somewhere here, so maybe you are going in this direction and in this direction. So, you may get this particular point. Now, if you are taking x naught somewhere here, then you may get this point, x naught somewhere here, you may get this particular point. So, therefore, depending upon what x naught you have chosen, so you will get one of the optimal solution. Okay. So, you may not get the global optimal solution, but you will get one optimal solution. Now, you look at this particular function. So, there are innumerable, there are a lot of local optimal solution and one of them is the global optimal solution. So, you have only one global optimal solution. So, somewhere here and others are local optimal solutions. Okay. Now, if you apply the classical optimization methods here, so you will get one of the local optimal solution. So, what you have to do? You have to change your initial point, and luckily if you are giving initial point somewhere here, so you may get the global optimal solution of the problem. So, therefore, this particular function is, therefore, it is not that easy to get the global optimal solution of this particular function using classical optimization method. Now, you know what is the disadvantage of classical optimization methods. So, let us look at the metaheuristic optimization. Now, metaheuristic optimizations methods are derived from different phenomena happening in nature. So, if you look at the nature, so intelligence in biological system. Now, let us start from this particular your circle competition. So, what is happening in nature? There is a competition, or we can say that we are struggling for survival. So, within the species or across the species, is not it. So, there is a competition, and competition is for the resources, for the survival. So, therefore, everyone will not be able to survive in nature, and you can say the fittest will survive. Those who are fit, those who are strong, those who are intelligent, they will survive. So, other people will not be able to survive because of competition, is not it. So, because of competition. So, this is one phenomenon which is happening in nature. Okay. Then another is learning. So, we are learning, not only the human beings, even the animals, even the ants. So, they are learning with the experience. Okay. With experience they are learning. So, they are learning, and you can say this is a trial and error based learning method. Okay. So, they are learning. Then they are also communicating. So, there is a very good mechanism to communicate each other. Okay. So, they are communicating with the your other individual of that particular species. So, there is a good communication method. Then swarming. Swarming is, so they are actually working in group. Okay. So, they are not working in individual, means suppose they are not working individually. Okay. So, they are working in group, and you can say the swarming. Suppose they are, when they are searching food, they are not going alone. So, they are going in a group, and they have a very good methodology to search the food, and basically it is a well organized. It is not arbitrarily they are moving from here and there and in search of food. So, they are moving in group or swarming. And reproduction. Reproduction means they produce offspring. Now, when they produce offspring, some of the offspring may be better than their parents. Okay. So, that means the offspring may be better than parents, or they may have the means better capability for survival. So, that is another your factor, or that is another factor what is happening in nature. Okay. So, these are, so now what we are doing basically, if you look at these natural processes, or if you look at the phenomenon what is happening in nature or intelligence in biological your system. Now, people are trying to look at this phenomenon, and if you are looking at it, everything is optimized. Suppose when this ant, they are searching for food. So, as I said in my first class also, so they have a very good communication technique, they are communicating each other, and they have a methodology to move in a shortest route basically. Okay. So, therefore, they are not moving arbitrarily. So, they have actually optimized the process so that they can reach or they can take the food using a shortest distance. Okay. Similarly, if you look at the other phenomenon what is happening in nature, they are also using, or their process are also optimized process. So, by looking at this your natural processes, so many researchers they have proposed the optimization method. So, we call it meta-heuristic optimization method. So, I will explain why it is meta-heuristic optimization. Okay. So, they have given different meta-heuristic optimization method for solving optimization problem. Now, some of the meta-heuristic optimization algorithms are genetic algorithm. Okay. So, inspired by the evolution process in nature. So, this algorithm. So, people are looking at the evolution process, and whether this evolution process is a random process or a guided process. So, it is not a random process, and based on that these algorithms has been you derive, or it has been proposed, and it is working fine in finding the optimal solution of the problem. Okay. Similarly, there are some other algorithms. So, this one is particle swarm optimization, and this is based on social behavior of bird flocking or fish schooling. Okay. So, what is the social behavior? Based on the social behavior of bird flocking or fish schooling. Okay. So, how they are searching food. Then similarly, the simulated annealing, this is inspired by the process of annealing in metallurgy. Okay. So, process of annealing in metallurgy. So, based on that, this simulated annealing algorithm has been developed. Then differentiation evolution, this is based on biology and the evolution of living beings. Okay. So, based on that, so it has been developed. Then Firefly algorithm, so this is inspired by the flushing nature of fireflies. Okay. So, flushing nature of fireflies. So, I will also discuss about this algorithm. Then there is another algorithm which is inspired by the spreading strategy of weeds. Okay. So, if you look at a paddy field or a cultivated field is basically captured by the weed. This is unwanted. So, this is based on the spreading strategy of weed. So, which are unwanted as you know. So, we call it invasive weed optimization. So, it is inspired by how weed is occupying the entire field. So, or it is an we call it invasive weed optimization. Okay. Now, ant colony optimization, in the first class introduction also I said about that one. So, ant colony optimization. So, it is inspired by food sourcing behavior of real ant colonies. Okay. So, how they are searching food. Okay. So, based on that this algorithm has been developed. So, inspired by the food sourcing behavior of real ant. Ant lion optimizer. So, hunting mechanism of ant lion. Okay. So, this is inspired by the hunting mechanism of ant lion. Then artificial bee colony algorithm. So, foraging behavior of honey bees. Okay. So, how they are collecting the honey in a honey bees. Okay. So, based on that or inspired by that mechanism, this algorithm has been proposed or it has been developed, artificial bee colony algorithm. Then bat algorithm, that is inspired by echolocation behavior of microbats. Okay. So, this is another algorithm. Then crow search algorithm. So, this is inspired by the intelligent behavior of crows. Okay. So, this is another metaheuristic optimization algorithm. Then cuckoo search algorithm. So, this is inspired by the reproduction of cuckoo birds. Okay. So, this is some of the metaheuristic algorithms. So, these algorithms are inspired by the different phenomenon what is happening in nature. And if you look at these algorithms, so they are not actually using the gradient information. So, that also I will explain. They are not using gradient information and they are only using the function value, but these algorithms are inspired by the different phenomenon, different activities happening in nature. Okay. Now, let me discuss what are the advantages of metaheuristic optimization method. So, the first advantage is does not require the derivative value. Okay. So, we do not use the derivative value either first derivative or second derivative. So, I do not need that one. Okay. So, I need not calculate the derivative value. Okay. So, this is you can say this is the main advantage of metaheuristic optimization method. So, I do not need the derivative information. The objective function and constraint need not be continuous and differentiable. So, the one of the limitation of classical optimization methods or one of the limitations is that the function should be continuous and differentiable, but in case of metaheuristic optimization method. So, this restriction is not there. So, function can be a discontinuous function, discrete function, non-differentiable function. So, you can solve the optimization problem having discontinuous function, non-differentiable function, and you can also solve the discrete problem, integer problem, mixed integer problem. So, therefore, the algorithms are suitable for solving optimization problem with discontinuous function. Algorithms are suitable for solving optimization problem having non-differentiable function. The algorithms are suitable for solving discrete optimization problem. The algorithms are also suitable for solving integer and mixed integer problem. Okay. So, another advantage is not works under the assumption that the problem is a convex problem. So, I can apply this algorithm for non-convex function. Rather, I will say that if your problem is a non-convex problem. So, I also discussed this thing earlier, that suppose how to select an algorithm. So, now you have different algorithms. Okay. Now, you have classical algorithm, now you have metaheuristic optimization methods. Now, for your problem, which one you will select? So, what I will say that if your problem is a convex problem, you go for classical optimization technique, because they are very good algorithm for solving a convex problem. So, if your problem is a convex problem, if you know that if your problem is a convex problem, you apply the classical optimization method. Now, if your problem is a non-convex problem, then you apply this metaheuristic optimization problem. So, I will suggest that you apply metaheuristic optimization problem. So, therefore, for non-convex problem, it is expected that the algorithm can locate the global optimum. Okay. So, it can locate the global optimum. So, in case of metaheuristic optimization problem, the probability is very high that you will get the global optimal solution of the problem. So, it will not, it will basically avoid the local optimal solution. Then user need not define a starting point. So, I need not define a starting point like classical method. I have to define what is x naught. Okay. So, x naught I have to define, and from there your search process will start, but in this case I need not define the starting point. Okay. Then it is inherently parallel. That means, if I want to apply parallel your computation, okay, so I can do inherently parallel, but the classical algorithms are sequential. That means, from you are going from one point to another, then you are going to another point, but here this is inherently parallel. Okay. Non-knowledgeable base optimization. So, here I do not want to actually, without knowing the nature of the function, actually you can apply this algorithm. So, non-knowledge based optimization process. So, without knowing it, suppose in case of classical methods, so you should know actually what problem you are trying to solve it. Okay. Otherwise, you may not get the optimal solution, but in this case I do not need the knowledge on the problem. Okay. So, without knowing about much about the objective function and constraint, so I can apply this, because I am not calculating the derivative, or it can be applied on a non-continuous your function also. So, it can be applied on a non-continuous non-differentiable function also. So, non-knowledge based optimization, easy to discover the global optimum. As I said, it is expected that the problem will give you the global optimal solution of the problem, easy to discover the global optimum, and can avoid trapping in local optima. So, I can avoid the local optimal solution. That means, suppose if your function is something like that, I would like to find out the global minima. So, I may get this particular, and similarly, if I need to find out the global maxima, that also I may get. So, I can easily avoid the other local optimal solutions. Okay. So, these are advantage of the meta-heuristic optimization methods. So, I would like to tell that meta-heuristic optimization methods are problem independent method. Okay. So, it is not depend on what type of problem actually you are trying to solve. So, it is independent of the problem. Now, as I said, now I can apply the meta-heuristic optimization method for finding the global maximum solution, global maximum or global minimum. So, I can apply here also, I can apply here also. Now, you look at this is a very difficult problem if you apply the classical optimization method, because so if you are putting this particular point as your x naught. So, you will get this solution. If you are putting this one, then you will get this solution. If you are putting somewhere here, you may get this solution, this solution, this solution. So, therefore, depending upon what x naught you are using, you will get one of the local optimal solutions. But if you apply the meta-heuristic optimization methods, so you may get the global optimal solution in a single run. Okay. Similarly, I can also apply the meta-heuristic optimization methods here. So, this is all about the introduction to meta-heuristic optimization methods. So, today I have introduced you what is meta-heuristic optimization methods. I also discuss the disadvantages of classical optimization methods. Okay. So, in many problems, if your problem is not continuous, non-differentiable, you will not be able to apply classical methods. Similarly, if your problem is an integer problem or a discrete problem, so you will not be able to apply classical method. So, to overcome those things, so these meta-heuristic optimization methods can be used, and this method can give you the global optimal solution of the problem, or your search process will not trap in a local optimal point. So, I can avoid the local optimal solution and I can get the global optimal solution of the problem. So, in the next class I will discuss genetic algorithm. So, this is one of the meta-heuristic optimization algorithms, very powerful in finding the global optimal solution of the problem. So, I will discuss these algorithms in the next class. Thank you.